Welcome back, College Algebra. This is going to be a video on section 8-2. If you remember at the beginning of 8-1, we said this chapter, the topic is called conic sections. And conic sections, there are four of them. Ellipses, which we did in 8-1, and hyperbolas is the second of the four that we'll do. We don't really hit on circles that much just because circles are something that you've done before in geometry, but we will touch on them. Anyway, so what we're going to do to, first of all, draw, to investigate hyperbolas. Let's just talk about, what is a hyperbola? Have we ever seen a hyperbola before? Well, you have seen a hyperbola before. Okay, probably in Algebra 2, it might not have been called a hyperbola, but if I graph even a simple function like y equals 1 over x, okay, if you take a minute to graph that on Desmos or your graphing calculator, you'll find out pretty quickly that it looks something like this. Okay. It has a branch here and a branch here. This is called a rectangular hyperbola, and it's not necessarily the type of hyperbola that we're going to study in 8-2, but this is a hyperbola. Because I want you to understand, you have seen a hyperbola before. A hyperbola has two parts to it. Notice it's got a branch here and then a separate branch down there. Now, like I said, that's not going to be the type of hyperbolas that we're going to study in 8-2. So when we first began our study of ellipses, we drew an ellipse and we drew all the parts to that ellipse. We're going to start the same way here. I'm going to draw a hyperbola, and we'll put all of the parts of a hyperbola on here. So I'm going to draw an x and a y coordinate plane with a great big quadrant 1, just because that's where I'm going to put my hyperbola. Okay, so let's start. I'm going to start by just kind of sketching two branches of a hyperbola here. There should be symmetry there. I think I've drawn it pretty well to where there's symmetry and such. It's not perfect though. Okay, so this is the picture of a hyperbola. Branch here, branch there. Now, let's talk about the parts of a hyperbola. First off, right in between the two branches, at the place where the branches are closest together, okay, is a point called the center. Okay, an ellipse had a center. A hyperbola also has a center. So I'll maybe make an arrow. This is the center of the hyperbola. And the coordinates of the center, if you remember the coordinates of the center of an ellipse, we designated them using the letters H and K for the x and y coordinates. It's the same for a hyperbola. The coordinates of the center are going to be H and K. Okay, so there's the center. Now the next thing I'm going to draw is I'm going to draw a dashed segment that goes from the center to each branch of the hyperbola. Okay, so that's like the shortest segment you can draw between the two branches of the hyperbola. And that, let's make this arrow come all the way here. And that segment has a name. That is called, I'll write it right here. This is called the transverse. Teddy, tell me if you can read this. What I just wrote there.
Yeah.
Okay. Transverse axis. Okay. The transverse axis goes through the center and it goes and it touches each branch of the hyperbola. All right. At each end of the transverse axis, we have what is called a vertex. So there is a vertex. There is another vertex right over there at the other end of the transverse axis. Okay. The distance from the center to a vertex, we denote that with a lowercase a. Similar to the way we denoted the distance from the center to a vertex on an ellipse with a lowercase a. Remember, we called that the length of the semi-major axis. I've never really heard the word semi-transverse axis used. but A does still represent half the length of the transverse axis. Okay. Now, there's a feature of a hyperbola whose purpose does not become clear until a little bit later. There's also a segment that kind of runs up and down. In this case, it runs perpendicular to the transverse axis. It passes through the center, and it has some yet unspecified length. Okay. We'll talk about how that affects the hyperbola when we do an example. But this is called the conjugate axis. So this segment that runs, in this case, vertically through the center, it is called the conjugate axis. Now, if you remember, an ellipse had two foci that kind of help determine the shape of the ellipse. A hyperbola also has two foci. This time, the foci with a hyperbola, instead of being closer to the center than the vertices, the foci of a hyperbola actually lie outside of the vertices. So they lie along an extended transverse axis. So there might be, if I extended the transverse axis past the vertex, I would get to this is called a focus. And there's another focus over here past the other vertex. Okay, so a hyperbola has two vertices and two foci. All right, now let me get a second color here, maybe. All right, the distance from the center to the end of the conjugate axis, that's denoted by a letter. You might be able to guess what letter that is. It's denoted by a lowercase b. And then the final distance that we have to worry about with a hyperbola is the distance from the center to a focus. And just like with an ellipse, the distance from the center to a focus is denoted with a lowercase c. Okay. So I think I have all the pieces up there for a hyperbola. Not all of them are going to completely make sense just yet. We'll have to talk about, especially that conjugate axis is kind of mysterious right now. How long is it? How does it affect what the hyperbola looks like? Well, that remains to be seen. Now, the two types of hyperbolas we're going to see in this section. This one has a horizontal transverse axis. Transverse axes will also sometimes run vertically in this section. Okay, we'll never see a tilted transverse axis, although they do exist. We don't study them in this course. So every hyperbola that you deal with will either have a horizontal transverse axis or a vertical transverse axis. This one, of course, has a horizontal transverse axis. The very next thing that I'm going to do is maybe at the top of the board space, it'll be easiest to read. I'm going to write the standard form of the equation of a hyperbola. Okay, so this is going to be, and I'll clarify this, but I probably won't have room to write down what I'm about to say. This is going to be the standard form of the equation of a hyperbola where it has a horizontal transverse axis. It's going to look like this. Okay, there it is. That is the standard form of the equation of a hyperbola that has a horizontal transverse axis. And now, look at that for a minute, and if we were in school right now, I'd be asking you all kinds of questions, and one of them would be, does this look familiar? And hopefully the answer would be yes, it kind of looks similar to the standard form of the equation of an ellipse. I ask you, well, what's different about it? Well, you probably notice there's only one difference. And that difference is the sign right there. If that were a plus sign, this would be the equation of an ellipse. But since it's a minus sign, this is the equation of a hyperbola. Okay. Now, I'm going to say this right now. The fact that the x term, the term with the x in it, is positive, that's what makes a hyperbola have a horizontal transverse axis. If the x term, oh my goodness, there's an ant in my house. Got it. I have a zero tolerance policy for ants. Okay. I think what I was saying was that if the x term, the term with x in it, were negative, and the term with y in it was positive, I would then have a hyperbola with a vertical transverse axis. It's easy to remember. X is the horizontal dimension. If x is positive, transverse axis is horizontal. Y is positive, transverse axis is vertical. Okay, now I'm going to erase this picture now. And we're going to graph a hyperbola. Okay, let me start over here. So I'll give you a second to look at that. Now I'm telling you this is the equation of a hyperbola. Here's how I would recognize this as the equation of a hyperbola. I have a term with y minus k squared over a variable squared. I have a term with x minus a quantity squared over a I said a variable squared over there, but that's not really necessarily correct. It's just over a number, okay? And I have a 1 over here, and I have a minus sign in between the terms. One of these two terms is positive, the other one's negative. So I know it can't be an ellipse, because if this were going to be an ellipse, this would be a plus sign. Now, notice, let's look at this. One thing I notice is that the term with y in it is positive. Term with x in it is negative. Well, if you remember what I said a couple of minutes ago, if the y term is positive, you're going to have a vertical transverse axis. So I'm going to make just a note here. I'm going to write VTA, vertical transverse axis, because I want to keep that in mind as I go to graph this. All right, let's begin. I'm going to write the center, the coordinates of the center. The center here looks like the x coordinate will be, remember that's x minus h, so h is 5. Y minus k, so k is 3. Okay. Now, look, you don't have to get hung up on what's a squared and what's b squared, or vice versa. The square root of the y denominator always tells you how far to go up and down from the center. That's the same as it is with an ellipse. The square root of the x terms denominator always tells you how far to go left and right from the center. If you can remember that's true for ellipses, it's true for hyperbolas. You don't have to worry about what's a and what's b, and so on. So what I'm going to do then is I'm going to draw a set of axes. Tell you what, let me move that y-axis over just a little bit. You'll see why. Okay, so my center's at 5, 3. Maybe I'll put that on there first. So 5, 3, uno, dos, tres, cuatro, cinco, uno, dos, tres. Looks as though the center of my hyperbola is going to go about right there. Okay, now, if you watch this procedure, you will never go wrong graphing a hyperbola. Okay, put the center on there first. Next, the square root of the y term denominator is 2, right? Square root of 4 is 2. That means I'm going to go 2 up, put a dot, 2 down, put a dot. Okay. So the square root of the y term denominator always tells me how far to go up and down from my center. The square root of the x term denominator, square root of 16 is 4. So I'm going to go 2, 3, 4 units that way. 4 units that way. All right, this is great. This is great. Now, let's talk about the box. Okay. What I'm going to do always now is I'm going to draw a rectangle. Okay, we call it the box. And I'm going to draw a rectangle made up entirely out of horizontal and vertical segments. And I've got to hit all 4 of those points that I just drew on there. It doesn't go through the center. Okay, it just goes through the 4 points shown here. I'm going to do this in red. So I've got to hit this point. If you're doing this at home, your rectangle hopefully looks a little bit better than mine does, right? But mine's not too bad. Okay. So I graphed the center. I went 2 units up and down. Square root of 16 is 4, so I went 4 units left and right. Then I drew a rectangle to hit all 4 of those points. Next thing I'm going to do, that's a rectangle. I'm going to draw what are called the diagonals of that rectangle. Diagonal of a rectangle passes through 2 of its corners, or its vertices. So what I'm going to do is, of course, I will pass through the center as well. There is one of the diagonals of the box. Now, I'm going to draw the other one. I'm drawing these just with light dashed lines here. This is a lot easier at, at a big whiteboard and such, like at school. Okay, now, let me tell you, everything that I've done so far would have been the same if this would have been a horizontal transverse axis hyperbola. But the time has come. I haven't drawn like the hyperbola at all yet, but we're ready to do that now. And what the hyperbola is going to do, okay, now remember, this is a vertical transverse axis since the y term is positive. So the vertices of this hyperbola are going to be here and here. And what will happen is the hyperbola will go through its vertex, and then it'll come out this way. And those diagonals that I drew serve as asymptotes for each branch of the hyperbola. So as I come out from the vertex, the hyperbola is going to approach the asymptote forever. But of course we know it's never going to actually touch or cross that asymptote. So there is one branch of the hyperbola. The other one, of course, is down here. It's going to go through this vertex. It's going to approach that asymptote. It's going to curve around like this. And approach that asymptote. That's a hyperbola. that one had a vertical transverse axis. If this would have had a horizontal transverse axis, of course, the branches would have passed through this vertex and this vertex, and they would have gone like that, and like that. All right. A little bit more information. Teddy, how are we doing time-wise here?
20 minutes.
It's not that long. All right. For a hyperbola, and only for a hyperbola, there is a relationship between A, B, and C. Now remember, there was a relationship between A, B, and C for ellipses as well. It was C squared equals A squared minus B squared. That was for ellipses. For hyperbolas, it is probably even easier to remember because it looks just like the way you have memorized the Pythagorean theorem. A squared plus B squared equals C squared. So if I ever don't know A, or don't know B, or don't know C, I can figure out the value. As long as I know any two of those, I can figure out the third one, the one that's missing. All right, now, the next thing that we're going to do is we're going to talk about, and this is something that we dealt with ellipses as well. Sometimes you'll get the equation of a hyperbola or the equation of an ellipse that's not in standard form. It's in what we call general form. Okay. And I'm going to write one up here. I'm just copying this out of the assignment. If you want to pause the video and go to your assignment, this is going to be problem 10. And, I mean, it's randomized, but 4x squared minus 24x. All right, so that is a 144 over there. Okay, so Teddy, can you see this okay in the phone?
Mm-hmm.
Okay, good. Okay, this is the equation of a hyperbola. Okay, now I have no idea what this hyperbola looks like. I don't know where its center is. I don't know whether it has a horizontal or a vertical transverse axis. I don't know anything about it. And I won't know anything about it unless I can rewrite this hyperbola in standard form. Okay. And to do that is going to involve completing the square. Okay, in more than one variable, in fact. Teddy, time?
23 minutes, 30 seconds.
All right, I tell you what, let me upload this one. I'll be back in a few minutes with the next one. Okay. Thanks for watching. Goodbye.